So let's assume this is 1.5. Now, oops. All right. Where do we get this data? How do, like, an immediate question would be, how did I come up with this data, right? If I had test results from say 10 different samples, all right, and again, what is definition of low, medium, high, that you have to come up with. Say for example, you have some test samples where two say a particular pesticide is varying between 2 to say 8. All right. So, and then experiment is done, and then I can give you like a made up table for the experiment. So you have, let's assume it is all 50, 20, and 30. So we know for sure that. So just little bit has increased because our data is cooked up data, right? Like no, we just made this up. But what you see from here is if you have a complex network and an end result, you know for sure that this is what happened, then you can do a diagnostic of the network and see what caused that problem to happen, right? This is a very powerful tool to have for a decision maker. All right, so this is another example. Okay, let's, this is little complex, so we will do this one here. So what we have here is an example for bird killings due to presence of windmills. All right. Okay. So what are the different nodes here? So this one I will do, and then we will. Like, I'm expecting that students as groups will come and solve the following example problems that we will do, right? So what is required here is you're looking at the deaths in birds because of windmill. So first, one node for sure is number of birds, like the presence of birds, right? So let's birds presence. All right. What else are the important factors in this scenario?
The windmill.
Hmm?
Windmill.
Activity, windmill activity, yes. But presence of bird, like is there something that feeds into the presence of birds? Migratory season, right?
Yes.
What season it is? So all right.
Food.
And what else?
Food.
So your final outcome is what?
There the
Final outcome.
The
That-
death of the
Um, your final outcome is bird killings, right? Okay, so presence of bird is there. You have migratory season. Bird killings is your final outcome. What else are the possible nodes? So once you just think of all the possible nodes, and then we will do the connection. So what else? How will you find out whether the birds, there is some inspection, right? A person will have to go and collect the birds. Only then you will get the data of how many birds were, he's killing, killing is high, low. How will you come to know?
GPS track.
GPS?
Track.
How many birds will put GPS? No, but how will you know the data, right? Somebody has to go near the farm, the windmill, and it will designate an area around the mill, and a wind turbine, and then he will do the visual inspection of the birds, right? So inspection. Okay. What else? What else, guys? Because the exercise that I'm doing now, I expect you to do it. So help me, and then it'll help you in the class later. What else? Think about it. I know, you usually when you're doing this, you're doing little bit of literature beforehand, right? You will study all that, and then you will try to find out the nodes. But we don't have that luxury here. So just on the cuff, think about it. So our end goal is to see bird killings. So for that we need bird's presence. What else? Presence of wind. It has to move, right? So presence of wind, right? Wind gusts or wind presence. Because if it is not moving, right? Then the possibility of hitting a bird collision is less. So wind presence. What else?
We need data on the existing bird population.
Yes. Bird presence. Migratory. One is migratory season, and existing bird population in the area. I'm trying to see how that would, because your understanding is that birds are already present in that area, right? But
Yes.
they are very transient population, so they keep moving.
Yeah.
So migratory season probably would add more sense in that way, because yes, it is in that migratory path. But yes, presence, you could say migratory path,
Yeah.
right? There is a migratory season. There is one season, right, in which there is in general presence of the birds, but the wind turbine could be sitting right through their path, right? Their frequented path. That could be a possibility, but I'll still hold on to that for now.
Professor?
Yes.
Time factor that during the daytime they would do the bird, but during the night or the evening they want the.
Yes. That's an important factor.
Right.
Daylight hours, right? So, with the understanding that during the during daytime, they could be less susceptible. That is the understanding, but it is a very flawed understanding. But still, I'll still keep it there. Yes.
And also, all the collisions may not be deadly. Some collisions,
I'm sorry. What?
all the collisions may not be deadly.
Ah, yes.
them only injured.
It's true, but we will consider a collision as like or a hit as like this one, because then it will become more complex. What you are saying is that there could be some birds which got hit, but would
it's not
recuperate
dead, it might be wounded.
later and stuff like that. It will get complex. All right. Any other? Okay. Let's try to put them into a network now. All right. So migratory season. What does this feed into, or what node? Yeah, what node this feeds into? Does it feed into wind presence?
Bird presence.
Bird presence. Okay. All right. What else?
Daylight hours to bird presence.
Daylight hours to bird presence. Yes. Okay.
Inspection too?
Wind presence
Would
to bird
daylight
killings.
hours also feed into bird killings?
Yes.
Okay.
Hmm.
And then
Wind presence to bird killings.
wind presence to bird presence?
No,
Bird
bird
killing.
killings.
Bird killing, yeah. Alright. And then inspection is feeding into.
Bird killings.
Now this is little complex, not as complex as you would expect it to be. Usually if you look at the journal papers on Bayesian, the networks are very complex. This is still a very fairly simple one. Alright. Can I have okay, another thing I forgot to mention
Wind
is, say, let's go to this network here. What happened?
Delete कर दिया इसे.
Oh, no. How am I? Oh, okay. Maybe I didn't save. That's why it is. Okay, carry on. Okay. One important thing that you have to keep in mind when you are doing the network is these are acyclic networks, which means that say for example you have 3 nodes here. Let me just draw 3 nodes. Alright, let me just draw 3 nodes. I'll delete it. So we have node 7, node 8, node 9. Alright, so we can't have nodes connections like this. You understand? Right? So why? Because it will become a cyclic network. So cyclic networks are like you can't make them. So yeah, the tool itself doesn't allow you, but all right. So we have developed one network for bird killings. Now let's see here. Again, developing the network, in my view, is because I've worked extensively on Bayesian. So I can say that with some authority that developing your network is the single most important thing in the whole research that you are doing. Once you have the network, everything else, getting data, synthesizing data is all becomes much easier. Alright, let's see here for migratory. Either you could have a migratory season or not, right? So yes or no? Two states. Okay, here I can give you an no, I can't now. Yeah, this is a good example instead of this complex one. Yeah, because suddenly you put me on the spot, and I was not able to come up with an easier example. Like this one, I can give you a nice little example. This is much easier. So the probability for migratory season, yes. How much probability can we calculate? All right. So we have here 12 months, right? Jan, Feb, March, April, May, June, July, September, October, November, December. All right. So let you give me exact number. Just let's assume what, like 4 months. 4 months is a reasonable assumption.
Yes.
So let's say here they are coming in
4 months.
April to, or maybe April to August, right? So this is the migratory season. So based on this information, can somebody tell me what is the probability numbers that I should give here?
0.3. Oh, 5 by 2.
Or make it one more month less. Make it
0.41.
from May, okay? Okay, now
0.3.
what is the probability of migratory season?
0.3.
Hussein will give me the answer for this. Because he said you were not able to understand last time, right? So you have this information. I'm telling you that May, June, July, August are the migratory season, right? So based on that, give me a probability number here. You want help, Hussein? You want help? Okay, fair enough. I can do that. So the probability season, yes, would be how many months in a 12? Like 1, 2, 3, 4. So 4 by
12.
what?
0.33.
0.33,
Yes.
right? So if that is 0.33, it will be 1 minus 0.33, right? Fair enough. So we got a probability number C. You just convert the data, like this is very simple example. It just occurred to me, but you can also do for like the toxicity data as well. Like take that data, synthesize it, make it into compartments, saying okay, if the exposure is 2 to 4, what is the mortality, right? Out of the total number of species, how many died, right? So you take that and you do the calculation. All right. So let's do the daylight hours. So
0.5.
for daylight hours, how would we do this?
Daylight 12 hours होते हैं ना.
This one also you can make an easy calculation. Just like how you did the migratory seasons, you could also try to come up with daylight hours for that.
Eight by 12.
So it depends on the
Yeah.
seasons, like in winters they are less daylight.
Yes.
hours.
So you take an average, like year long, what would be the so you have this data. I think
10 to 12 hours.
yeah, but then for the whole year, right? When you're doing it for the whole year, because it is being operated for the whole year. If I was doing some research in this kind, what I would do is I would also add the time